All right. Hello, hello. I think this is my first lecture of this year. So, what my plan is today is to kind of finish up some of the things I would have gone over if I was there. And then hopefully at the end you'll have some time to finish planning your video and maybe making some of it too. Just a reminder, make sure you're loud enough on there. You don't have to scream, but just be loud. Also, let's see, Monday, summaries are due at the beginning of class, and the video is emailed to me Monday night at some point. I said 8 o'clock. I'd like to stick to that, but if you're having issues, we can talk about that too. All right, so we basically hit all the brain parts. Now we're just talking about some of the bigger ideas that are associated with your brain. And then Monday we'll talk about kind of an accompanying module that relates kind of to our biology. And then Tuesday's our test. There is a short answer on the test. Okay. So have you ever heard of being left-brained or right-brained? Probably, right? That's a pretty common thing that at least gets tossed out there. Is there a problem with that? Yes and no. But basically, our brain works together. That's the main idea, right? Is that we're not just a right-brained individual or just a left-brained individual. We work together. However, like we already learned a little bit, that we do have areas in our brain that are specialized, like our hippocampus, memory and amygdala, and speech in general. But I just don't like that myth there. There's another myth that is from a movie recently, and Mr. Martian makes fun of it all the time, but it's like, we only use 10% of our brains. No, that's not true either. Now, what it's getting at is that in one instance, no, you're not using every single part of your brain, but it's not 10%. There's no way to really quantify that. Okay, so back to kind of the left brain and right brain. There is some truth to that, and this is what I want to show you. So our brain, we've talked about this, is divided up into two hemispheres. So our left is reading and writing, speaking. We talked about speech being on the left, right? Mathematics and comprehension. By the way, feel free to pause me whenever you want to while you're writing notes. Okay? And then your right hemisphere, this is more of kind of maybe bigger picture stuff. So you've got perceptual tasks. Do you know what that is? So you do this a lot in some of intelligence tests where you're trying to put things together. For the next one says visual spatial. That reminds me like Tetris, trying to be able to fit things together. Or packing the trunk of a car. Some people are terrible at that, and don't have that that. I'm not going to call it intelligence there, but that ability is lacking. They always say that mom or dad supposedly are better at that. That's usually a dad packs the car, that kind of thing. But that's using kind of your visual, and spaces as well. And then our emotion gets processed on the right side as well. So if looking at kind of the left here versus the right, what I see is very specific kind of tasks in the left, reading and writing and speaking, and that's all language related, right? But then you get math, and then the right are more kind of big picture ideas. I am going to, I'll give you a little handout on Monday if I remember, to see, so you can kind of see which way you lean. Again, where some of us are very balanced, but some of us lean one way, and you might be able to guess right now which way you lean. Okay, I'm going to show you a picture. Don't be biased. I just want you to look really quickly at them and which one is happier. Okay? Don't overthink it. Which one is happier? Or you can compare my face down there too. No. Okay, you got your choice. Most people say this right one, the one on the right. Interesting. Not everybody, but most people say that. Why is that? Okay, remember how we talked about how our brain kind of controls the opposite side of our body and the opposite side of our vision as well? Remember how our vision kind of crosses? Okay, so if you look here, wait, did I mess that up? I did mess that up. I'm sorry. Just kidding. No, I got it right. Just kidding. Try to get me. Okay. Okay. Emotion is in the right side of the right hemisphere, right? Okay, so it's in your right, and then think about it crossing to the left side for vision. So if you look at this guy on the right, he's got a smile on the left side of his face. So that's in our left visual field, but it comes across to our right where emotion is processed. And so, I mean, that's why most people think that the one on the right is happier. If you're not, then you just, maybe something messed up. I'm just kidding. Okay, so we talked about this already, right? Splitting the brain, the corpus callosum, and treating severe epilepsy. And we left off with this. Okay, so things in the left visual field over here. Okay, come over into your right. And then the same thing here, the right visual field over here comes over to the left. And speech is over here on the left, right? And so people who have this cut to treat epilepsy, it's severe epilepsy. That's medicine's not working. Okay, so the apple comes over here. They can say, oh, I saw an apple. And then over here, the pencil comes and it can't cross over here. So they cannot say that they saw a pencil, but they did see a pencil. Now, how do we know that? Because they can draw it with their what hand? If it's in the right hemisphere, which hand do they draw it with? Good job. I think you said left. Okay. All right, cool. Okay, so this is where I gave you the video. If you'll pause it and go watch that video, and you can see what someone who actually has had their corpus callosum cut, how this actually works. It's pretty fascinating. It's old video. I'm sorry, but it's good. Okay, and then unpause me. Okay, if you want to, you can look at these. I'll put them up on the screen. You can pause them and come up with your answers if you want. But I'm just gonna roll through it. Again, feel free to pause. Okay. All right. This is kind of, we got 2 ideas left to talk about. Brain plasticity. Okay, is our brain made of plastic? No, you know the answer to that. So what does this mean? Plastic. Do I have anything plastic around here? Nope. Okay. Plastic is bendable and it's moldable. That's kind of this idea here. Your brain is very moldable. And this is seen most when people get in car accidents or have some kind of surgery where if part of the brain is taken out. If one part of the brain is damaged, your brain is so kind of moldable there that if this side is, or a part of this isn't working, the rest of your brain takes over and is able to accomplish most of those tasks pretty well. Okay, so there's your definition. The brain's ability to modify itself after some type of injury or illness. Okay, so for example, if you lose a finger, your other fingers become more sensitive. And what part of the brain is responsible for being more sensitive? Sensory cortex. Okay. Oh, you can't see all this. So when someone is blind, their fingers, so their other senses basically rev up and their brain takes over that function there, and it revs up. So for example, they need their touch, like specifically with Braille. And so the brain area for that, for your fingers, basically is able to kind of rev up there because of the loss of the other brain area. And that makes sense too, like if someone's blind, the same thing goes for their hearing, their touch, taste, all that. So here is a pretty serious example here. This is called a hemispherectomy. And again, this is severe seizures where medicine's not working. Maybe they even tried to corpus callosum and it's still not working. And basically their brain isn't allowing them to function at a normal level at all. A lot of people can't walk, can't talk, can't function very well. And so this is kind of the last case scenario, but they have done this. It's called hemispherectomy, and they take out a whole hemisphere. Now, you would imagine that would leave them with severe issues afterwards. But what's surprising is it's not really. I mean, yes, compared to normal people, normal brains. But not really. They can there's a TED Talk on this that I want you to watch. The first 6 minutes. I'm sorry. Why isn't this working? There we go. And what they talk about is their language is able to still recover. Their mental abilities, their personality. What has most been able to not be plastic, he says, this doctor, is their motor abilities aren't quite as good. So for example, if they take out your right hemisphere, what side of the body is not going to function as well? The left side, right? The opposite. So it's pretty fascinating, but basically this is just an example of your brain being very plastic and being able to take over and modify itself. And one side note, they really only do this with kids, because kids are the most plastic. Their brain has the most plasticity. And I mean, you kind of know that, as kids, if they break a bone, it's not quite as difficult to get over later in life. And a lot of different, even if they fall, hit their head, a lot of times they're going to still be okay compared to adults. Okay, so go watch that, and then I got one last thing, okay? Now, this is the last thing. So I'm just going to briefly talk about this, being left-handed and right-handed, because that is your motor cortex, right? And so it goes to the opposite side of the brain. And so it's interesting that most people are right-handed and the minority is left-handed. It is inherited, so it is genetic. So I know we have two lefties. And are your parents lefties as well? Okay. Oh, sorry. Okay, so if you think about, like I said, speech is in the left hemisphere. That is a general statement, because if you look at this, 95% of righties process speech in the left hemisphere. However, lefties mix it all up. That's not exactly true for them. 25% of lefties process speech in the left. So it's almost like their brain is flipped a little bit. 25% of lefties use both for speech, and then 50% use right. Isn't that fascinating? So left-handed people, you guys are crazy different. And this is just, thinking about how that is a minority group of people. I'm sure they can vouch for being left-handed is sometimes difficult. A lot of equipment is made for right-handed people. Scissors, desks, not our desk. I'm old school, had those desks where you slide in and you write. You've got something here. I don't know if you know what I'm talking about. There's so many examples. I just had another one. Oh, this is just writing. Left-handers struggle on any kind of writing because they smear it as they go. So poor left-handers, right? Now this is kind of silly. I know this comes from 1993, but look at this. The percentage of left-handed individuals decreases sharply in samples of older people. What does it mean? There's not as many people in the older sections that are left-handed. It's a little bit morbid if you think about it. Left-handed people kind of die earlier. Now this is 1993, and it's changed a little bit but a lot of it's just equipment-based issues. And no, this does not mean if you're left-handed you're going to die earlier at all. Correlation does not prove causation, right? Okay, well that's it. Hopefully you are fascinated by the brain. I am. I think it's one of the coolest and craziest and mysterious things in a lot of ways of our bodies. And it dictates almost everything we do. All right. That's it. Peace.